All right, I'm joining you this morning for one quick amendment on one of yesterday's examples on using the first derivative test. I'm going to walk you through this example, spell out some key points, and also give you some guidance on what kind of answers I'm looking for on those follow-up questions for our assignment today. So the problem in question today is this natural log function and finding a relative min or max in that natural log function. I know that was kind of difficult, and these have been difficult for us. So how to find the natural log derivative. All right, so if we look at our reference sheet, if you have it, there's something like if ln of u, right, then if we take the derivative, our derivative is 1 over u times u prime. So what does that mean? It means for any natural log function, if you just take whatever's on the inside, just keep that thing, but put it on the bottom of a fraction, and then multiply by the derivative of that bottom. So kind of like the chain rule with inside and outside, but this time the inside's going on the bottom of a fraction, and then you multiply by the inside's derivative. So if I look at this natural log function here, the inside is x. So we're going to have something like 1 over x, and now I have to find the derivative of x. The derivative of x is just 1. So 1 over x times 1 is just 1 over x. So in something like this, in order to find natural log derivatives, I need to use this formula. So now I have f prime of x equals 1 over x. And don't forget to take the derivative of this next term, which is just going to be negative 1. So this is going to be our derivative so that we can find those critical points. We're going to do this by setting this equal to 0. And then solving just like we did yesterday. So I'm going to add 1 to both sides. Remember that when we find the derivative, any value that has a derivative of 0, we're finding that kind of horizontal tangent where we're thinking, okay, maybe it's coming up to a max or min, or maybe it's just leveling out for a second. And then from here we can use cross multiplication and division, or just kind of see that 1 divided by 1 is 1. So one of our critical points is x equals 1, which is no different than yesterday. But what is different from yesterday is that I have to look for other critical points that maybe don't have a derivative of 0, but anything else that is undefined. So this is going to be the only point that has a derivative of 0 or a horizontal tangent, right? But I also have to look for undefined points. Well, let's look back to this fraction. What would make this fraction, this x value, undefined? Well, what is the rule of fractions? I can't divide by 0. So it's also going to be undefined at x equals 0. So that's another critical point. Now that's not going to be a maximum or minimum because that doesn't have a derivative of 0, but it's going to tell me something very specific that's happening at my graph. So let's look back to the original function. Why can't I have 0? If I look back to the original function, remember that like an old rule of ours is with log. In natural log, we can't have an argument that is 0, and we can't have an argument that is negative. It has to be a positive argument, right? Because it's like an answer to an equation problem. If I raise something to a power, I can't get 0, right? So with that being said, we can't include any negative numbers on our number line. For this number line today, we're actually going to start our number line at 0. And just use the right part. And once again, it's because anything in the negatives or below 0 is going to be undefined in our regular function. We can't use 0 or negatives in natural log and log. So we're going to actually start our number line at 0. So think about this graph is only going from 0 and to the right. And the only critical point here is 1. And this graph is going to go all the way to infinity. So now we need to actually find our critical points, use our critical points to find what's happening within this set of values. So what stinks is this time, the only thing that we can plug in to find out what's going on is 0.5. So remember that we're going to plug that into the derivative. So 1 over 0.5, so let's find f of 0.5 equals 1 over 0.5 minus 1. And when you actually do this math, 1 divided by 0.5, you can use a calculator for that. That's going to give you 2 minus 1, which is just 1. Now remember that all we really needed to do there was know if this was positive or negative. The first derivative test allows us to know if a function is increasing or decreasing on a given interval. So on this given interval, our function must be increasing because the derivative gives us a positive value in that interval. Now we know that our derivative here is 0, so it's going up and it's flattening off. But we do need to find our derivative on this interval. So once again, the first derivative tells us that if we want to find if the function is increasing or decreasing on this interval, we can just plug in a value into the derivative on that interval. So this time I'm going to plug in 2 into my derivative formula. So 1 over 2 minus 1. Now if I do the math here, it'd be like 0.5 minus 1, which would be negative 0.5. I don't need the negative 0.5, but I do need to know it's negative because that's going to tell me that my function is decreasing. So with that being said, we know now because of this function that we have to start at 0 and that we're going up because the slope is positive, and that we're going to level off with a slope of 0, and then we're going to decrease because the slope is negative. So that tells us that at x equals 1, not only is it a horizontal tangent, let's see, that's going to be going up and down. That must be a local or relative maximum as well. So to justify our answer here, we would say x equals 1 is a relative, or we could just say is a maximum, because, and what would be my reasoning here? Because the derivative at x equals 1 is 0, and the function increases on the interval 0, 1, but decreases on the interval 1 to infinity. Okay, I hope that kind of summarizes some things yesterday. I'm going to have you go to that check for understanding, fill out some questions as just a follow-up. That's going to be your lesson for today. You can see me in office hours. They're going to be optional. I hope this helps you guys. Please check in. Do not feel, just feel free to reach out at any time. Adios.